The photograph looked like a smudge. A faint red thumbprint pressed against the black. Then the numbers came in, and the room went quiet. That smudge was a galaxy. It was sitting 300 million years after the Big Bang, and it had no business being that heavy, that structured, or that old. Within weeks, more of them appeared, massive, organized, wrong. Then came the black holes, already grown, already feeding, already impossible under the physics we had. James Webb was built to confirm the story of how the universe assembled itself. Instead, it started dismantling it, piece by piece, image by image. The press releases said stunning. The papers said in tension with the standard model. Those are not the same sentence. Something is off in the sky. Not in the telescope, in the model we brought with us. And the further out we look, the worse it gets. I want you to sit with that for a moment. Wherever you are watching from, whatever time it is where you live, I want you to consider what it means for the most expensive, most precise, most anticipated telescope in human history to start returning data that its own designers cannot fully explain. Because that is what is happening. And the way it is being explained to the public is not the way it is being discussed in the field. The optimism sold to you goes like this. James Webb is peering deeper into cosmic history than any instrument before it. It is finding galaxies that formed earlier than expected. Isn't that amazing? Isn't science wonderful? The reframe is beautiful, and the reframe is a shield. Because behind that language, cosmologists have been quietly using words like crisis, tension, and revision. Adam Rees, the Nobel laureate whose team first detected the accelerating expansion of the universe, has publicly called the parallel Hubble tension a genuine emergency. In 2023, Ivo Labbé and his collaborators published a paper in Nature describing 6 candidate galaxies from JWST that contained roughly 10 billion solar masses of stars, existing when the universe was between 500 and 700 million years old. Their conclusion, phrased in the polite prose of peer review, was that the observed stellar mass density was in tension with the current cosmological model. Translated into ordinary English, these things should not exist. And they do. That is the pattern that keeps repeating. Every few months, JWST releases another image. The public gets wonder. The field gets a headache. And the headache is not a small one. Because when a telescope built specifically to test a scientific model keeps finding things the model forbids, you eventually have to stop blaming the telescope. You have to start looking at the model. And when you look at the model, you start realizing how many of its assumptions were quietly load-bearing. To understand why any of this should bother you, you have to understand what the standard model of galaxy formation actually claims. And this is where it gets uncomfortable. Under lambda cold dark matter, the framework that has held for roughly 40 years, galaxies are supposed to be built the way coral reefs are built. Slowly, gravitationally, piece by piece. First, dark matter clumps together into invisible halos. Then, gas falls into those halos. Then, the gas cools slowly enough to form stars. And critically, the process is capped.
only a small fraction of the available raw material, typically between 2 and 20%, gets converted into stars in any given epoch. This is not a guess, it is derived from decades of observation, from the Kennicutt-Schmidt star formation law, from stellar feedback physics, from supernova energetics, from the way ionizing radiation from young stars pushes gas back out before it can collapse further. It is a hard number, and it has been tested in thousands of galaxies across billions of years of cosmic time. Now hold that number in your head, 2 to 20%. And then look at what JWST is measuring.
Some of these early galaxies imply star formation efficiencies approaching 100%. Nearly every available atom of hydrogen and helium in a young dark matter halo converted into stars in a window of time so short it should be physically impossible. Think about what that means. It is not that the recipe cooked faster than expected. It is that the recipe, as written, cannot produce the cake. The oven is not hot enough. The ingredients cannot combine that quickly. And yet the cake is on the table. Warm, complete, waiting for us to explain how it got there. Now think about what that really means. The recipe for making a galaxy, the one printed in every cosmology textbook written in the last 40 years, is missing an ingredient, or a step, or a mechanism. And nobody knows what it is. There are proposals. Perhaps the very first generation of stars, the population 3 stars, were more massive and more efficient than we thought. Perhaps early feedback was weaker, letting gas collapse more freely. Perhaps the initial mass function of those stars was skewed toward monsters. Each of these ideas patches one hole and opens another. None of them so far closes the accounting. Here is where the story gets worse. Because the problem is not just how fast these galaxies grew, it is how they are shaped. Under the old picture, when we looked at the very early universe, we expected to see chaos, irregular blobs, clumpy mergers, what astronomers used to call train wrecks. That is what the Hubble Deep Field prepared us for, the nursery phase. Galaxies still figuring out what they wanted to be, colliding with each other, spraying gas across space, gradually settling into the shapes we recognize today. Instead, JWST is finding orderly, rotating disk galaxies at redshifts above 7, when the universe was less than 750 million years old. In 2023, Christopher Ferreira and colleagues showed that classical Hubble tuning fork morphologies, spirals and disks and mature structures were already common when the cosmos was a small fraction of its current age. ALMA observations of some of these systems confirmed cold, rotating gas disks where none should exist yet, spinning smoothly, dynamically stable, behaving like galaxies that have had billions of years to sort themselves out, not tens of millions. Think about that comparison for a second. It is like finding a fully formed skyscraper in the fossil record of the first single-celled organisms. Not almost, not partially, fully. That is not a small correction to the model. That is the model waving a white flag. The Hubble tuning fork itself, that neat evolutionary diagram in every introductory astronomy textbook, showing galaxies growing from irregular blobs into ellipticals and spirals over cosmic time, may need to be moved back by billions of years, or scrapped entirely. And if the galaxies are too mature, wait until you see what is sitting inside them. This is the point where the intuition of gradual growth breaks completely. Because JWST, working alongside the Chandra X-ray Observatory, has started identifying supermassive black holes that should not be there yet. In 2023, Akosh Bogdan and his team reported UHZ-1, a supermassive black hole with a mass in the tens of millions of solar masses, detected in a galaxy at redshift 10.3, when the universe was about 470 million years old. And then came the little red dots, hundreds of them, Compact, red, unresolved objects, many of which appear to host actively feeding black holes, weighing in at millions to hundreds of millions of solar masses, in galaxies whose stellar populations are far too small to justify them. Here is the number sequence that should stop you. In the local universe, in galaxies like our own Milky Way, the central supermassive black hole weighs roughly 0.1% of the total stellar mass of the galaxy, 0.1%. In these early JWST systems, that ratio can be 10%, in some cases higher. That is 100 times off. So imagine walking into a hospital nursery and finding an infant with the skeleton of an adult. Not a growing skeleton, a completed one. That is what these black holes look like relative to their host galaxies. The proportions are wrong. The developmental sequence is wrong. The order of construction seems inverted. They cannot have grown that fast under standard accretion physics. The Eddington limit, the maximum rate at which a black hole can pull in material without blowing it back out again by radiation pressure, does not allow it. Not from stellar mass seed black holes formed in the deaths of the first stars. Not in the time available between the first stars igniting and these giants appearing. Do the arithmetic. A 10 solar mass seed black hole, accreting continuously at the Eddington rate from the moment the first stars died, would take roughly 1 billion years to reach 1 billion solar masses. But JWST is finding these black holes in less than half that time. The clock has not run long enough. The math simply does not close. Every proposed mechanism runs into a wall. Direct collapse of enormous primordial gas clouds into black holes of 10,000 solar masses, skipping the star phase entirely, requires very specific and rare conditions that may not have been common enough to explain the number of early black holes we are seeing. Super Eddington accretion, where black holes somehow break the radiation limit for extended periods, has never been reliably observed at the scales required. Hidden merger cascades require populations of intermediate mass black holes we have never directly detected. Every route ends at a locked door, which forces the darker question: what if the universe itself is older or built differently than the timeline we are using? What if the clock we started counting from does not begin where we think it does? That is not a fringe idea being whispered by cranks. That is a possibility appearing in serious theoretical papers, discussed cautiously, entertained more and more openly, precisely because the alternatives are running out. This is the part where I have to stop and remind you what this really means. Because it is easy to hear phrases like tension with the model and think that this is a bureaucratic problem for a few hundred cosmologists. It is not. Every atom of iron in your blood, every atom of oxygen in your lungs, every calcium atom in your bones was forged inside a star and released into the universe by that star's death. That is not poetry, that is chemistry. If we cannot explain how those stars got there, we cannot fully explain where we came from. When the origin story of matter itself starts breaking down at its earliest chapters, the story of you starts breaking down with it. Your body is, quite literally, a chapter written in a book we are no longer sure how to read. And this is not being received calmly inside the field. Read the interviews, Scientific American, Nature, Quanta, the science pages of the New York Times. Senior astronomers using words like panic, others describing sleep deprivation, others using the word existential. Michael Boylan Colchin, a theoretical astrophysicist at the University of Texas, called some of the earliest JWST findings a potential crisis for cosmology in interviews shortly after the first data releases. These are not people prone to melodrama. These are people whose careers have been built on the model that is now generating errors it was never designed to handle. A generation of astronomers may have spent their working lives building on a foundation the next generation will have to demolish and rebuild. The last time science lived through something like this was the collapse of the pre-Copernican geocentric worldview. It took over a century to work through. And it did not just change astronomy. It changed philosophy, theology, politics, and the human sense of self. When Galileo pointed his telescope at Jupiter and saw moons that clearly orbited something other than the Earth, that was the equivalent of what JWST is doing now. A small observation, an impossible implication, a century of consequences. Galileo did not live to see the resolution, neither did his students. The transition took generations, and it was painful, and it was contested, and it eventually rewrote everything. We are, potentially, quietly, living through a comparable inflection right now, and the majority of the public has no idea it is happening, because the language used to describe it has been polished into something too smooth to feel. And here is the harder truth. The problem is not just what JWST is seeing. It is what JWST cannot see, no matter how long it stares. We are already close to the physical limit of what optical and infrared astronomy can extract from the early universe. Beyond about redshift 15, individual stars cannot be resolved. The Lyman break, the wavelength cutoff imposed by neutral hydrogen absorption in the early cosmos, sets a hard wall on how much detail we can pull from these ancient sources. Redshift confirmation itself, the process of proving that a distant object really is as far away as it looks, requires enormous amounts of spectroscopic time on JWST's near-spec instrument. JWST is booked years out. Its fuel supply, the propellant that keeps it stationed at the second Lagrange point, roughly 1.5 million kilometers from Earth, is finite. Current estimates give it around 20 years of useful life, and every additional observation burns time and station-keeping fuel. Beyond that, the mirror drifts and the mission ends. And the next generation of instruments is not coming quickly. The Nancy Grace Roman Space Telescope, launching later this decade, will help with survey area, but not with the resolution of individual anomalous sources. The extremely large telescope on the ground in Chile, with its 39-meter mirror, will begin science operations later, but it fights the atmosphere and cannot match JWST's infrared sensitivity for the earliest galaxies. The Habitable Worlds Observatory, NASA's proposed successor for the 2040s, is at least 15 to 20 years out, if it survives budget cycles at all. None of these will fully resolve the paradox on their own, which means we are not going to build our way out of this in the near term. More data has been arriving continuously for 3 years, and the crisis has not softened. It has sharpened. Every new spectroscopic confirmation of a redshift makes the problem worse, not better, because it removes the last easy escape hatch, the argument that some of these distant galaxies might not really be as distant as they look. We may spend the next 30 years stuck between models we know are broken and models we cannot yet test. There is a historical echo here that is worth naming. In the year 1900, physics was confident. Lord Kelvin famously suggested that there was nothing new to be discovered in physics, and that all that remained was more and more precise measurement. Almost everything seemed accounted for. There was just one small anomaly, the ultraviolet catastrophe. Black body radiation behaving in a way that classical physics could not explain. It looked, at the time, like a footnote. It was not a footnote. Resolving it required the invention of quantum mechanics, which then rewrote everything from chemistry to electronics to the structure of reality itself. Every device you touch today, every transistor, every laser, every solar panel, exists because of that footnote. Anomalies of this kind are not always small. Sometimes they are the seed of the next century of science. And while all of this is happening inside the field, the institutional messaging remains suspiciously calm. This is where I want to be careful, because I am not saying NASA is lying. I am not saying the European Space Agency is hiding data. I am not saying JWST is a failure. In fact, the opposite. JWST is succeeding so completely, so precisely, so far beyond expectation, that it is breaking the very model it was built to confirm. That is a triumph of engineering. It is also a crisis of theory. And the two do not translate cleanly into press releases. There are structural reasons the public gets wonder while the field gets vertigo. Space agencies operate on multi-year funding cycles. They depend on congressional appropriations, on public goodwill, on the political viability of the next mission. When a $10 billion instrument produces results, those results have to be framed as vindication. The alternative, publicly declaring that the results have generated a foundational crisis, is not a viable communication strategy for an organization that needs its next budget passed and its next flagship telescope funded. So the word surprising does an enormous amount of work. In the papers, the same finding is described as in strong tension or difficult to reconcile within current frameworks. The pipeline from peer-reviewed manuscript to press release routinely files down the sharpest edges, replaces cautious hedges with celebratory framings, and quietly deletes the sentences that would make a reader ask uncomfortable questions. This is not conspiracy. It is not corruption. It is the physics of institutional communication. But you should know it is happening. Because the public is being handed wonder, while the field is quietly grappling with something closer to vertigo. And the deeper you go, the more you realize the galaxy problem was never really about galaxies. The JWST anomalies do not sit alone. They land on top of a set of tensions that had already been growing for years. The Hubble tension is the most famous. Measurements of how fast the universe is expanding, when derived from the cosmic microwave background left over from the Big Bang, give one value, around 67 kilometers per second per megaparsec. Measurements derived from nearby supernovae and other distance indicators give a different value, around 73. The gap between these two measurements is now around 5 sigma statistical significance. That is not a rounding error. That is not a calibration issue anyone has been able to identify despite years of trying. Two ways of measuring the same universe are giving different answers, and the disagreement has been getting worse, not better, as the measurements have gotten more precise. Then there is the S8 tension. Measurements of how clumpy matter is on large scales, derived from the early universe versus the late universe, also disagree. Not as dramatically as the Hubble tension, but consistently across multiple independent surveys. There is the missing satellites problem, where simulations predict far more small galaxies orbiting the Milky Way than we observe. There is the core cusp problem, where the density profiles of dark matter halos in simulations do not match what we see in real galaxies. There is the fact that after more than 4 decades of direct detection experiments, in the deepest mines and the coldest laboratories on Earth, in xenon tanks and germanium crystals, cooled to fractions of a degree above absolute zero, shielded from cosmic rays under thousands of meters of rock, we have never directly observed a single dark matter particle. Every candidate ruled out, every detection null. The theoretical parameter space for what dark matter could be has been shrinking year after year, and the closet keeps getting smaller. WIMPs, once the leading candidate for what makes up 85% of the matter in the universe, have been squeezed into a smaller and smaller corner of possible masses and interaction strengths. Axions are still on the table but remain unseen. Every year, another experiment reports another null result, and another swathe of theoretical possibility quietly closes. JWST did not create the crack. JWST widened one that was already there. And when you put all of these tensions together, the standard cosmological model, lambda cold dark matter, starts looking less like a settled theory and more like a very useful approximation with an increasing number of loose seams. Dark matter itself, dark energy, cosmic inflation, the age of the universe. All of it is quietly on the table in a way it has not been in a generation. I want to bring back the Michelson-Morley experiment here because the echo is precise. In 1887, two physicists set up an experiment to measure the speed of the Earth through the luminiferous ether, the substance that was believed to fill all space and carry light waves. They expected a clear signal. They got nothing. Their experiment quietly killed the ether. And that null result, that inconvenient no answer, eventually forced Einstein to invent special relativity, and then general relativity, and then the entire architecture of 20th century physics. GPS satellites work because of that null result. Nuclear energy exists because of it. JWST may be doing the same thing to something we have not yet named. And we may be one of the few generations to actually live through the collapse of a physical worldview and the birth of its replacement. Which brings us to what the evidence, taken honestly, is now pointing toward. Here is the verdict, not the polite version, the honest one. James Webb is not showing us a broken galaxy. It is not showing us an anomaly. It is showing us that the universe we have been describing to ourselves for the last century contains features we do not understand. Massive galaxies that formed impossibly fast. Mature disks that appeared in an epoch that should have contained only chaos. Supermassive black holes that arrived already gigantic, weighing more relative to their hosts than any late universe analog. And behind them, the older tensions that were already growing. The Hubble discrepancy, the S8 discrepancy. 40 years of null dark matter searches, a cosmology that has been quietly bleeding for years, that JWST has now made impossible to look away from. I want to strip one last comfort away. The instinct when hearing all of this is to reach for reassurance. Someone will figure it out. Physics always figures it out. And maybe, but the honest scientific position, spoken out loud, is that we may not sort this out in our lifetimes. Kuhn-style paradigm shifts do not happen on quarterly earnings schedules. The last one, quantum mechanics and relativity, took roughly 30 years from the first anomaly to a workable new framework. The one before that, the Copernican revolution, took over a century. There is no guarantee the next one will resolve faster. There is no guarantee it will resolve at all in a way our current mathematical tools can express. Now return to that opening image, that faint red smudge pressed against the black at the edge of the observable universe. It is not just a galaxy. It is not just a distant object. It is a message, written in ancient light, that took over 13 billion years to reach us, and its content is unwelcome. The message is that our map is smaller than the territory, that the framework we have been using to describe reality is incomplete, in ways we are only beginning to see, that the story we have been telling ourselves about how everything got here has a hole in its first chapter, and we cannot patch it with what we currently know. And here is the narrow hope, because there is one, and it is worth stating clearly. This is exactly how physics has always advanced. Not through confirmations, through anomalies that refused to go away. The ultraviolet catastrophe, the Mercury perihelion precession that Newtonian gravity could not fully explain. The Michelson-Morley null result. Every one of them looked, at the time, like a problem. Every one of them was a doorway. The crisis is the doorway, and we are standing at one right now, uncertain but not empty-handed. I want to be careful, one more time, about what I am not saying. I am not saying science has failed. I am not saying JWST was a mistake. I am not saying the universe is unknowable, or that physics is a fraud, or that any of the researchers working on this are anything less than serious, careful, and honest. What I am saying is that the map we brought is smaller than the ground we are walking on. And for the first time in a generation, when astronomers look at the deep sky, they are not confirming what they already know. They are being told, gently but unmistakably, that they do not know it yet. We built a $10 billion instrument to see the beginning of everything. It is one of the greatest engineering achievements in the history of our species. A folded, gold-plated mirror unfolded in the dark, 1,000,000 miles from home, cold enough to hear the first light of creation. And what it found, when it opened its eye, was the end of a story we had been telling ourselves. Not the end of science, the end of a chapter. The next one has not been written yet, and nobody, not the astronomers, not the theorists, not the agencies, not the textbook publishers who will have to eventually rewrite everything, knows what it will say. That faint red smudge is still there, still traveling toward us at the speed of light, still older than it has any right to be, still refusing to fit into any category we currently possess. And every time JWST turns its mirror in that direction, it sends back the same quiet, patient message. You do not understand what you are looking at yet. You built a beautiful instrument. You pointed it at the deepest sky, and what you found does not match the picture in your book. Which means the honest thing, the only honest thing left to do, is to keep looking, to sit with the discomfort, to let the model break if the model has to break, to follow the evidence into whatever new shape it wants to take, even if that shape is stranger than the one we started with. Because that is what science, at its best, actually is. Not the confirmation of what we already believe. The willingness to be wrong about something fundamental and to keep looking anyway. There is a temptation, at moments like this, to reach for tidy conclusions. To say the model will be patched, the anomalies will resolve, the next paper will fix it. And maybe it will. But the pattern of the last 3 years does not suggest that. The pattern suggests that every new observation makes the picture more strained, not less. That every new spectroscopic confirmation removes another comfortable escape hatch. That the field is moving, slowly and reluctantly, toward the recognition that something at the foundation is off. The universe is not obligated to fit our story. And right now, from 13 billion years away, it is telling us so. Quietly, patiently, in light that has been traveling since before the Earth existed. In photons that left their source when there was no sun, no solar system, no planet to eventually receive them. That light is here now. It is landing on a mirror we built. And it is saying something we did not want to hear, which is that the story is not what we thought, and we are going to have to write a new one.